Alright guys, so now I just want to switch gears a little bit and talk about the most important mechanism that benzene undergoes. And that mechanism is called electrophilic aromatic substitution. So in prior videos, we've already discussed that benzene really doesn't like to react with anything. And the reason is because it doesn't want to break its aromaticity. We've already learned how to test for aromaticity, and we know that if any of those 4 tests of aromaticity are broken, the molecule will become less stable. So let's look back at a reaction that we learned a long time ago and see how that would apply to benzene. Like, for example, halogenation. Halogenation was a reaction that took a diatomic halogen, halogenation, and added it across a double bond, and you would wind up getting a dihalide as a product. Now that we have 3 double bonds, you may think that halogenation would happen 3 times and just completely halogenate the ring. But now we understand why this reaction is not favored, right? Because the product is going to be non-aromatic. Why would this molecule be non-aromatic? What rule is it breaking? Well, written here, this is not fully conjugated, right? Since it's not fully conjugated, a not fully conjugated product is, guess what? It's less stable. Because now this molecule doesn't have aromaticity to help it out. So what that basically means is that typical addition reactions across double bonds are shot. They're not going to work on benzene. So how can we get benzene to react with anything? Well, let's theorize here. Let's be scientists. If we could somehow get benzene to react in a substitution reaction instead of an addition reaction, like for example, let's get some reagent and get it to switch out with one of the hydrogens. This is not a mechanism, by the way. I'm just saying, if you could just get them to switch, then your final product would remain aromatic. So this is the thought process that we go through when we say, hey, if we're looking for a reaction that's going to work on benzene, it needs to preserve aromaticity at the end. Well, how do we do that? It turns out, guys, that very, very strong electrophiles, that would be like an E+, right? Electrophile. It's an electron lover, okay? Something with a positive charge. Can temporarily disrupt that aromaticity to create a substitution product, as long as by the end of the reaction, it goes back to being an aromatic compound, okay? This process is what we call electrophilic aromatic substitution, or what I'm going to continue to just call EAS for short, okay? And this is by far the most important mechanism of benzene, and one that we're going to spend several hours discussing in the next few videos, all right? So let's go ahead and take a look at the general mechanism of EAS.